Hello everyone. In this presentation, I'm going to explain the trigonometric ratios and how to use the trigonometric ratios in order to find the sides and the angles of the triangle, or especially the right angle triangle. So using the trigonometric ratios depend very much on labeling the triangles. So let's see how we can label our triangles. In any right angle triangle, we have one hypotenuse. The hypotenuse is the longest side in the triangle, and it is the one opposite to the right angle. As you see here in this slide, we have one hypotenuse in the triangle that is the opposite to the right angle, and at the same time, don't forget that it is the longest side in the triangle. Then identifying the opposite and the adjacent sides depend on the place of angle theta. Here in this example, as we can see that this is a right angle triangle. B is angle that is equal to 90 degrees. So in order to find the hypotenuse, it is the side that is opposite to the right angle, which is the side AC. So AC is the hypotenuse of this triangle, and this triangle has only one hypotenuse. Let's see this exercise. B, find the side opposite to angle A. So angle A here has one opposite side. The opposite side to angle A is side BC. Why BC? Because BC is opposite to the angle. What about the adjacent side to angle A? The adjacent side is the side that is next to the angle. So what is next to the angle? We have AC, that is the hypotenuse. So what is the other side that is next to the angle is AB. So the adjacent side to angle A is side AB. Then we will find the opposite side to angle C. The opposite side to C is AB. What about the adjacent side? The side that is next to angle C. Next to angle C, we have AC, or side AC, but this is the hypotenuse. So what is the other side that is next to the angle and not the hypotenuse? It's BC. So BC here is the adjacent side to angle C. So labeling the triangle is very important in order to solve any trigonometric problem. Here guys, we're going to solve this example. In the diagram that is shown, it is a right angle triangle, and we need to find its hypotenuse, the side adjacent to angle theta, and you can see angle theta, which is angle BAC or CAB. And then you need to find the opposite of the same angle theta. Okay. Again, the hypotenuse is the one that is opposite to the right angle and the longest side in the triangle. So you can see that it's very easy. It is side AC or line segment AC. Then find the adjacent. What is the adjacent? Again, the adjacent is the side that is next to the angle, and at the same time, it's not the hypotenuse. So look at the sides here. What is next to the angle theta? It is AB and AC. But AC is the hypotenuse. So it can't be the hypotenuse and adjacent at the same time. So then the adjacent to theta is AB. What about the opposite? The opposite is the side opposite to the angle, which is BC. Okay, here guys, it's time to be familiar with the trigonometric ratios. The trigonometric ratios is sine equal opposite over hypotenuse, cosine equal adjacent over hypotenuse, and tan equal opposite over adjacent. Okay, so what would help you a lot in memorizing that is the acronym the acronym SOCA2. So refers to the sine rule, K refers to the cosine rule, and TO refers to the tan rule. Okay, let's apply please. What is sine theta in this triangle? As for this right angle triangle, you only have one hypotenuse as I told you before. So the hypotenuse is C. C is the line that is opposite to, or the side that is opposite to the right angle. And of course the longest side. So what about the opposite of theta? Look at theta please. You're going to find it. It has only one opposite side, which is B. So sine theta is equal B over C. What about cosine phi? Cosine phi, look at phi please. Again, cosine is adjacent over hypotenuse, and the hypotenuse is always C. What about the adjacent? Look at phi please. It has two sides that is next to it. One of them is C, which is the hypotenuse. It can be the adjacent. So the other one is B. So B is the adjacent, is the side that is next to the angle. So cosine phi equal B over C. As for tan, tan is opposite over adjacent. Okay, the acronym TO is coming from it. Opposite over adjacent. Okay, so the opposite to theta again is B, and the adjacent to theta is A. Why it's A? Because it is the side next to it. Yes, C is next to it too, but remember C is the hypotenuse. It can't be the adjacent and the hypotenuse at the same time. So tan theta is equal B over A. So why guys do we need these trigonometric ratios, sine rule, cosine rule, and the tan rule? We need that in order to find the sides and the measure of the angles in any right angle triangle. So remember how you are going to use the sine, cosine, and tan to solve triangles, finding its sides. Okay, so we need to set up the equation first, and then we need to solve this equation and find the unknown. Here we have two examples in order to find the unknown sides. Let's proceed, please. Okay, in this example, guys, we have a right angle triangle. What is given in this triangle is the angle and a side. This side is the hypotenuse. Why it is the hypotenuse? Because it is the side that is opposite to the right angle. We have the measure of this side equal to 9.6. So the hypotenuse is 9.6. And we have a given angle and we need to find x. What is the measure of x? X is considered the opposite side to angle 61. It is the opposite side. So we have hypotenuse and opposite. So which rule we're going to apply? I think we're going to apply the sine rule. Remember? So sine equal opposite over hypotenuse. So here we have a given angle. So sine 61 is equal to x, which is the opposite, over 9.6, which is the hypotenuse. So this is literally an equation that you can solve. So by solving equation, you need to multiply sine 61 by 9.6 in order to solve for x. Then by using your calculator, sine 61, close your brackets, multiplied by 9.6, so it's given 8.40. Okay, in this example, we have an angle which is 41 degrees in a right angle triangle, and we have a given side which is the opposite to the angle, and it is equal to 7.8. So we have an angle 41, an opposite side, and we need to find out x. X is the adjacent to angle 41. It is the side that is next to angle 41. So we have opposite and adjacent. Let's see which rule we can apply. Remember, so, ka, to. What had the opposite and the adjacent? It's to. So we're going to apply the tan rule. The tan of the angle is equal to opposite over adjacent. So we have tan 41 equal the opposite, which is 7.8 meters, over x. Then solving for x again, solve it as if you are solving any equation. So it's tan 49 multiplied by x equal 7.8. Then we need to make x the subject of the formula. We need to solve for x. So x equal 7.8 divided by tan 41. Then by using your calculator, you're going to find out that the measure of x is equal to 8.97. Thank you guys.